Okay, here's the circle with the sector that's going to be the uh, flower bed. It's got a radius of r for the circle, and the central angle is theta in radians. And over here, I've mentioned two formulas dealing with circles when the central angle is in radians. The arc length, this arc right here of the sector, is theta r. And the reason is because theta is a fraction of the entire uh, radians around the circle, 2 pi radians. So this is a fraction of the entire circumference. And the 2 pi's cancel out. So this arc length is theta r. And similarly, the area of that sector is theta over 2 pi. That's the fraction of the entire area, which is pi r squared. One of the pi's cancels out. So the area of a sector is 1/2 radius squared times theta when theta is in radians. Okay. And one of the conditions of the problem is that the perimeter of the sector must be 50, because that's we got 50 feet of interlocking stone available. So that means that this r plus theta r has to always be 50. So if that's true, theta has to equal 50 over r minus 2. You can follow the algebra here. And now we can find the area of a sector depending on just r, because we can replace this theta for this particular problem with 50 over r minus 2. And if I distribute, removing the parentheses, I get 25r minus r squared. We could find, that's the equation of a downward opening parabola. So we could find the vertex of that parabola and find the place or r value that generated the maximum, or we can use calculus, first derivative test. So a prime of r is 25 minus 2r. Set that equal to 0 to get critical numbers. The only critical number is 12.5. And here we use the first derivative test to prove that that 12.5 is generating a maximum value. So 12.5 is where the first derivative equals 0. To the left of 12.5, use a test number like 10. We get a positive, which tells us that a is increasing. To the right of 12.5, a prime is negative. Like put a 20 in there and you can see it's negative. So the original function is decreasing. That tells us that at 12.5, we've got a relative maximum. And here's kind of some proof of that. I've let f of x represent that 50 over r minus 2, which is really an expression for theta in terms of r. And here's the function for the area of a sector depending on, I could have put a capital R here. But you can see right here, it looks like the maximum area when you have 50 feet of stone is 156.25, and the radius must be 12.5. Okay, there you go. Hope that helped. If you have any questions, post a